Hello and welcome to the talk, Replatforming with Minimal Drama and Downtime. I'm super excited to share my story, and I want to say thank you to HashiTalks for giving me a platform to share that story. So let's get started. My name is Elijah Voigt. I am a senior platform engineer at a company called Lob, and I am, for the past year, have been the Nomad migration captain at our company, leading the charge on that project. I'm based in Portland, Oregon. I'm an avid runner and hiker, and that is a picture of me in front of the Painted Hills in Oregon, which is a beautiful geologic formation. If you ever get a chance to see it in person, I encourage you to do so. It's otherworldly. Let's go over an agenda for the next 30 minutes, shall we? First off, I'm going to say hello. Hi. Then we're going to talk about where Lob started and why we chose to replatform. It's not something that we took lightly. So what went into that choice? We're going to talk about the replatforming effort, both the technical and the social plan, and how it went. Then we're going to talk about some learnings, some surprises, both good and bad, on Nomad. And then we'll wrap up. Before that, though, I want to stress that this talk is meant to be inspiration for your replatforming journey. It's not meant to be a set of best practices. It's not even meant to be a mandate that you should use Nomad. Nomad works really well for us at Lob, but it might not be the right fit for you. As you watch this talk, I want to challenge you to think about where your story is similar and where it differs from my story. Maybe you're at a much larger company or a much smaller company. Maybe you value downtime differently. Either it's you have a lower tolerance or a higher tolerance. Maybe you have just different goals in replatforming entirely. Or maybe you're not even thinking of replatforming. I still think there's some value in this talk, and there's some kernel that you can take away from it. So keep the wheels turning and yeah, enjoy. Thank you. Lob's mission is to connect the world one mailbox at a time, which means that we have an API that you can use to print and send mail to one person or a million people, whatever you want. We have analytics, on-demand pricing, the works. It's a SaaS product for sending physical mail. And as a company, we have about 40 engineers and 150 employees total, distributed mostly in the US, but growing around the world. We have about 70 services that we run for internal and external use. This is a mix of containerized, serverless, periodic, and manually triggered pipelines. And in 2022, we sent 374 million pieces of mail, which means that if you live in the US, you have probably gotten at least one piece of mail from us in the past 8 or so years. I should point out that that's not 374 like evenly spread throughout the day, throughout the year. We get huge spikes right before we have a printer cutoff, where after that time, printers do not guarantee that your mail will be sent that day. And so we get huge spikes right before the cutoff. And that means that we have really tough challenges because we have this SLA where we have to guarantee that if you get it in before the cutoff, it will be printed and mailed. So we're not like a Netflix or a Blizzard. We don't have quite the same scaling challenges that they do, but we're not, we do have a pretty low tolerance for downtime, especially during those key windows. So to understand why we replatformed, we need to talk about what the old platform was, what its strengths were, and what its weaknesses were. Because like I said, we didn't take this lightly. We knew that replatforming would be a huge endeavor. And when you can, you should try to make the platform you have work. So where were we? We were using a SaaS product, which was a wrapper around AWS Elastic Container Service, or ECS. It offered a lot of nice features, like the configuration language looked a lot like Docker Compose, so it's pretty easy to get started for developers. It handled build and deploy and auto scaling, which is really nice. And it could host most simple applications. If you just had like a REST server, you didn't really care about the details, or if you just had an async worker, it could handle that super well. And you've never heard of it, I'm not going to name it, but think of it as a middle ground between Heroku and vanilla ECS. So it had some out of the box features, some batteries included, but it also gave you a little bit of ability to dig into the hardware if you want it. And we had used this for about 4 years, and we were starting to hit the ceiling of what it was capable of. We started to need to develop apps that it couldn't quite support, or that we had to make compromises to fit on this platform. So we were struggling to meet product demands and scale with the platform we were on. For example, the service was really not very discoverable. So when we would onboard new developers, and even old developers at Lob would struggle to do basic operations, everything was done through the CLI. The user interface was really lacking. And you could dig into AWS to fix issues and troubleshoot there, but it was unclear when the wrapper expressed that something broke, where in AWS you should look to fix that. So it was just really opaque, really hard to dig into. It also wasn't very flexible from an app architecture perspective. Like I said, it can handle REST and async workers pretty easily. But if you cared about needing specific hardware, or even we had one service that had to terminate TLS itself, the app code had to terminate TLS, but all of our applications were behind a load balancer that terminated TLS for us. Like I said, in most cases, that's fine, but this one app basically had to bring its own platform. We had to deploy it outside of the normal flow, which just means that one service is really hard to maintain. And there was a growing number of these one-off cases. So that's the app side, or the app dev side. From the operations perspective, it was also pretty inflexible. Clusters couldn't run mixed instances, so you couldn't have like memory optimized and CPU optimized in the same cluster. We couldn't add spot instances. It was all spot or no spot, which is just a really good cost-saving measure. And we couldn't have a mix of different operating systems or additional hardware, like if we wanted graphics cards or a different variant of Linux, we just couldn't do that. Now, none of these alone would kill the company. And in fact, if we had kept using that platform up through today, we would probably be fine. But we asked ourselves, do we want to use this platform in 5 years? And it quickly became clear, no. We tried to work around these issues, and we settled on, we need to replatform this. Where we are today, we cannot tune our way out of this problem. So we asked ourselves a bunch of really hard questions. And we decided that we wanted to build one platform that could handle all current and future services, which clearly the current platform couldn't do that. There were already services that didn't fit. We wanted it to have flexible operations so we could meet both service needs and cost reduction needs. So as we scaled up, we wanted to be able to save money by adding spot or adding a variable amount of hardware, or optimizing hardware for an application, etc. And we wanted to make sure that when we did this migration, it was zero downtime and minor velocity impact. Those are 2 points that I want to stress. We didn't want to impact customers, and we wanted to impact developers as little as possible. Those were 2 things that we as a team knew were key to the company, and we took seriously ourselves. So how did we choose Nomad? Nomad's a really weird choice. I think it's obvious that if you're thinking of replatforming, if you didn't know about Nomad, you would just say, oh, we'll just use, for example, Kubernetes or Mesos or one of the other myriad of choices. So how did we land on it? Well, it's a little circumstantial. One of the people on the platform team had prior experience with Nomad and could vouch for it. So we knew anecdotally that it would work. And we tried deploying a test cluster. And the test cluster was super easy to set up. HashiCorp had some Terraform that we forked, and we built upon that. And we got a few of our applications running and did some load tests, and they worked as well or better on the new platform with the new architecture. And so we had confidence, not just that people say Nomad works, but that we had used it and we had positive experiences with it. Once we had agreed that with ourselves and with leadership and with other teams, we just sort of said like, hey, we need to replatform. We think we're going to go with Nomad. I know this is controversial, but we've tried it and we think it's the best choice for our company. We spent about 6 months architecting the migration and architecting how Nomad would work at the company, and we went about doing that work. Here's an overview of what our architecture looks like. It's a little hard to read, but if it's too small, I apologize. I'll try to walk through the flow. We use AWS for everything. So we use Route 53 for DNS. Requests go to an application load balancer. So we're still using application load balancers. We can use load balancers that do not terminate TLS if we need to. Requests get sent to Nomad clients, which are all running a traffic or Trafic sidecar that handles requests once they enter the cluster. Trafic is a really nice, very simple container load balancer. There's other ones like Envoy, but we settled on Trafic for simplicity. Once a request enters a Nomad client, Trafic uses Consul's service catalog to figure out where that request should land. And the request goes to any number of containers for that service, round robin. And we have Nomad servers and for the control plane for orchestration, and Consul servers for service catalog. Consul has a lot of cool features that we're not taking advantage of, but for now, it's used heavily as a service catalog. And I think that's it. Yeah, this is just to ground us going forward. So we're all on the same page for what even are we talking about? What architecture do we choose? Oh, and we have 3 to 5 Nomad servers and Consul servers. For lower environments, we have 3. For production, we have 5. So that was the architecture we settled on. And now here's the migration plan. We knew we wanted to migrate service by service. Many of our services have similar, but none of them are exactly the same. And so we needed to give each one tender love and care to make sure that its unique patterns and its unique requirements were met on the new platform. We didn't want to do the thing where you migrate everyone over and then you flip a switch one day. We wanted to make this slow and steady. So for a long time, app teams would actually have services on the old platform and the new platform, which is overhead, but we wanted to simplify things and make sure we weren't aggressively changing faster than we needed to. It was a calculated risk, and we decided to go a little slower than maybe some teams might. We also focused on lift and shift. And when I say that, I mean we tried to get the app working on the new platform exactly the same as it worked on the old platform. Isolate as many variables as possible and just get it working. This is kind of a gift and a curse. We weren't taking advantage of a lot of the cool features that Nomad and Consul and even Vault could offer, but we focused on getting it working. And once we're on the new platform, then we can more tightly integrate with the tools that we have available. So for example, like Nomad has, when you update a variable in Consul or Vault, it'll restart the container if you want. We don't do any of that. So that's actually a source of friction for us, but we're focusing on getting on the new platform before we start to adopt features like that. As far as getting the migration going, we'll dive deeper into this, but we did traffic shaping is what we call it. I think it's a fairly common word for it, where at the load balancer level, we direct some percentage of traffic to the old platform and some percent to the new. Once we've fully migrated to the new, we switch to a different load balancer that doesn't have traffic shaping, but for a period of time, traffic is split between the old and the new platform so that we can quickly roll back if we need to using Terraform. We did that traffic shaping. And then as we're migrating traffic, that can take days or weeks. We tuned scaling and deploys and dashboards and made sure that app teams knew that the service was running on the new platform and felt confident in the ability of the new platform to handle spikes in load, etc. So it was very slow and steady. And of course, we did all of this in pre-prod environments before ever doing it in prod. So we practiced and recorded any problems that we had. I gave this talk to my team a few weeks ago, and one piece of feedback they had was to talk more about traffic shaping because it was really cool what we did, or I think it's pretty cool. So let's talk about traffic shaping and how we implemented that because it might be useful for you. Most of our services have a subdomain like foo.lob.com that was already pointing to the ECS service. So we added a route or rule to that load balancer that would split some percentage of traffic to the new, some percentage to the old. And we did that configuration with Terraform. Once a request enters the Nomad cluster, it's routed by traffic to the appropriate container. So that was not, as far as Nomad was concerned, as far as Platform V2 was concerned, and as far as ECS or Platform V1 was concerned, once the request entered, it didn't know about traffic shaping. So traffic shaping was isolated to the load balancer. During the migration, though, we also had a totally separate route that traffic could take, that requests could take, called like foo.apps.lob.com or some special subdomain that would never be traffic shaped. That would always go directly to Nomad. And that allowed us to isolate is if we saw problems, is this a problem with Nomad? Is this a problem with the new platform, the old platform, or the code? And so we could isolate problems that way. And like I said, once we were fully traffic shaped over, we would update DNS to point to the new load balancer that was not traffic shaped. And the whole time we did this, we were deploying updates in our pipelines to the old platform and the new platform, so code stayed in sync. Great. Now that was the technical challenges. Let's talk about the social challenges. So we created a kind of a role, kind of a pseudo role called migration ambassador. And so for every team and every service, there was a migration ambassador who was meant to be point person. They invested time and energy into understanding the team's needs, any workflow problems that they had, or just weird quirks that they had for how they did work. And you could DM them or talk to them directly whenever you had a problem. You didn't need to just ask the platform team because that can be intimidating. The reason we created this role is because, well, when I talked to my manager about this talk, I originally had a slide later on that said change is stressful. And he actually said change isn't stressful. Change handled poorly is stressful. And so this migration ambassador, and really all of this, is meant to get ahead of that problem and to handle that change in a way that brings people along and brings them into the fold. And we don't want anyone to feel abandoned or left behind. The worst thing that can happen is when your company says, hey, we're using this new tool. I know it sucks. Deal with it. We didn't want that at all. We wanted to be very collaborative with the people we were basically our customers, right? So in addition to the ambassador role, we also wrote a lot of organization-specific docs. So we had a playbook on how to do something on Platform V1. We updated it for Platform V2. And we could then show people how it's actually easier on the new platform because we've automated stuff. And we wrote a lot of docs that showed you the subset of Nomad that you need to care about. right? There's a lot of really good documentation for Nomad, and only some of it matters for you, right? There's like just common patterns that we have, and a lot of stuff that's not relevant. We didn't include that. We also use some code generation tools to translate the old Platform v1 configuration to the new one. So that Docker Compose formatted file that I talked about earlier, we wrote some code to translate that into Nomad HCL just for us. It wasn't perfect, but it got us 80% of the way there. And the whole time we were making very regular, thorough, and public updates where we celebrated victories, we owned up to our failures, and we updated people on timelines and told them why the timeline was changing. In addition to the curated experiences, I want to talk about the long tail of a project like this. I'm sure some company can just bust this out in a quarter, but this took us a whole year. And we were able to take our time, though, because we were pretty methodical in how we attacked this problem. So we started with some quick wins. No one really wants to be the guinea pig, but once you prove it out, more and more people are willing to try something. But no one, in my experience, no one wanted to be the first service on Nomad. So we chose some services that our team owned or that kind of no one owned really, and we deployed those to Nomad first. That proved that it could run code and it could handle pipelines. And eventually, more and more people were willing to adopt it. I want to caution you to take on the big fish about the halfway point. So we have this main API that's sort of the central point for all requests coming in. And we migrated that at about the halfway point because if we had waited till the end, people would get really nervous. They would say, well, and in fact, they were already saying like, well, can it handle all of what our customers can throw at us? If you only migrate small stuff, you won't know until the end if it can actually handle the big stuff. So by tackling the big one halfway through, you've proven that it can handle traffic, but you're not saving it to the end because that can be really stressful because you actually don't know if the new platform can handle what your customers can throw at it or what amount of effort needs to go into getting the platform up to speed. So by proving at the halfway point, you also buy yourself time. People are more patient with you and they're like, well, you've proven that it can do what we need, and now it's just a matter of wrapping up the rest. Things will also take longer than expected. On your current platform, you have tuned your platform to your needs. And if it's a new platform, you just haven't done that tuning yet. So just be patient with yourself. You need to tune as you go. And don't forget to celebrate your victories. Don't lie, but just when something good happens, be very vocal about it. Show people and tell them why it matters and try to connect the dots for people because it's easy to kind of just go heads down and fix something and get it working. But you want to get recognition for what you did because this kind of thing is really hard and it's worth bragging about a little bit. So how did it go? Well, we are currently about, 95% of the way migrated. There's a few services that need to be neither auto-scaling tuned, but once those are done, we'll be completely done. Feedback has been mostly positive. People love the new user interface that Nomad brings. People love the discoverability of the interface, which I also really like. And people still have constructive criticism that deploys are too slow, which was true on the old platform, and observability needs to be improved, which was also on the old platform. That's the how it went socially. How it went technically is that we had 21 total incidents. Each of those was about 10 to 30 minutes, and they ranged in severity between Sev 1, which is the worst or most severe, and Sev 4, which is basically just developer impact, our developer impact. 10 of those were because of app misconfiguration. Think under-provisioned resources, Nomad's not auto-scaling as expected, things that are isolated to one application. 7 of those were cluster misconfigurations. So we under-provisioned our control plane early on, or we didn't have auto recovery enabled for some mission critical service. And then 4 of those were operator error. So like I would fat finger something That was pretty common, or at least four times common. And all of this was within our error budget, which we were very vocal about and very transparent about. Whenever we had an incident, we would reflect and say, what do we need to do to prevent that? And how is that going to change the next 2 or 3 sprints? Cool. So some things that we learned. There's a lot that's really good about Nomad. The developer experience is great. We have really good metrics. Like we caught some bugs because we got out of memory out of memory killed metrics that we didn't have before. So there were actually a bunch of services that used to fail because they ran out of memory. We just had no idea. Scheduling affinity is awesome. It allows us to mix hardware in one cluster. I love that. And we only use open source Nomad, which is constantly improving. So I actually have a Slack channel that sends me the release notes every time a new version comes out, and I'm giddy to read those. So I cannot say enough good things about Nomad, but here are some things that we wished we had known earlier that were surprises. Auto scaling is something we use heavily at Lob, and it is pretty opaque. It's hard to ask and answer why something happened. There's also some auto scaling gotchas, like the Nomad APM only returns the latest data point. It doesn't return like an average over a window, which is kind of weird and surprising for us. Nomad defaults can be surprising for like scheduling containers. So the delay between removing a container from Consul and shutdown of that container is 0 seconds by default. But because we're using traffic to route requests, there's a race condition where containers can still receive requests even though it's been shut down or being shut down. In Nomad 1.4, there was a bug that stopped Nomad from allocating new containers just through some failure mode. And this got into production and we couldn't roll it back. And so that was fixed, thankfully. And it was actually fixed in a pretty reasonable amount of time. And the discussion in GitHub was super transparent. But that was kind of a pain point for us, especially because we auto scale so much. And this one's on us. Use the reference architectures. This was not super clear to me, but HashiCorp has reference architectures for Nomad and Consul and Vault. Use those. They will tell you like the right instance sizes. It's really useful. The instance size you use to test Nomad is not what you should go to production with. I'll just say that. Cool. So takeaways. Collaboration is key. I encourage you to listen, empathize, tailor your docs, and try to reduce burden whenever you can. You are domain experts, and so you can, as an ambassador or as a platform team, automate a lot of the toil of this migration for developers, for your customers. Be very conscientious about downtime. Have an error budget within your team and talk about that openly, I think. And like I said at the beginning, blaze your own trail. This is not a one-size-fits-all story, and try to think about where this does and does not fit for you and how you can make it fit. One more thing I want to tell you about. We wrote an autoscaler plugin for CloudWatch APM. So if you're interested in using that, if you're a heavy AWS user, we use this. It works for us, and you might get some mileage out of it. PR is welcome. I want to say thank you for your time. I want to thank my team for making this project possible. Thank you, Lob platform team. And again, I want to thank HashiCorp for giving me a platform, pun intended, I guess, for giving this talk and sharing my story. So thank you.